Bismillahirrahmanirrahim. Friction in horizontal motion. There is a crate of 500 Newton and it requires 230 Newton force to move this crate, and once this crate starts moving you have to need only 200 Newton force to keep this crate at constant velocity, and we have to find the coefficient of static friction and coefficient of kinetic friction. In both the cases, when the crate is at rest or crate is in motion, there is no change in velocity, means acceleration is zero, means the body is in equilibrium, so we will use the Newton's first law of motion. First we have to identify the relevant concept. As the crate is in equilibrium position in both the cases, we have identified that Newton's first law will be first ordered variable is coefficient of static friction and other is coefficient of kinetic friction. Next step is setup. So first we will draw its simple sketch, and then we will draw a free body diagram of the crate just before starting. So first we put a dot for the crate representing crate, and first force is a weight that is acting downward, and other is the normal reaction that is in upward direction, and a force of 230 Newton is applied by an external source. As a reaction of this force, frictional force is also produced in opposite direction. Applied force 230 Newton was applied on this crate, and the crate does not move, and there appears static frictional force in the opposite direction that balances this 230 Newton force, and the crate is in equilibrium and crate does not move. So this is the free body diagram. Next we have to attach a set of coordinate axes. X-axis along the direction of application of the force, and y-axis perpendicular to this direction. And next step is the execute. Newton's first law will be applied. Sigma Fx is equal to 0. So force is on one side is 230 Newton and on the other side is Fs maximum. So applying this formula we can calculate the value of Fs maximum as 230 Newton. Again applying Newton's first law, sigma Fy is equal to 0. Upward force is N and downward force is 500 Newton, that is weight. So from this equation we can find the value of normal reaction as 500 Newton. We know about this formula, Fs maximum is equal to mu Sn, and we have to calculate mu S, coefficient of static friction. So after putting the value of Fs maximum and N, we will get mu S as 0.46. There will be no unit of this coefficient of static friction. Next we will draw a free body diagram of this moving cart. When the force was applied of 200 Newton and there is no change in velocity, and the body will be again in equilibrium. So let us draw the free body diagram of a moving crate. First we place a dot that is representing the crate. First force is the weight that is acting in downward direction. Other is the normal reaction that is in upward direction. And 200 Newton force was applied in one direction, and in the opposite direction kinetic friction appeared. So next we have to add the set of coordinate axes. X-axis is along the direction of application of force and y-axis along perpendicular to it. Again in this case the crate is in equilibrium, so we will use Newton's first law of motion. Sigma Fx is equal to 0. Along x-axis 200 Newton force is applied in one direction, in the other direction F of k force is created. We can calculate the value of Fk is equal to 200 Newton. Again applying the Newton's first law of motion in component form along y direction, sigma Fy is equal to 0. So from here again we can calculate that value of N is equal to 500 Newton. Next we have to calculate the coefficient of kinetic friction. We know that this formula Fk is equal to mu Kn. From here mu k is equal to F of k over N. Taking the value of F of k of 200 and N value of 500, we will get mu k value as 0.4. Next step is to evaluate. We have calculated the value of mu S as 0.46 and value of mu k as 0.4. We have calculated that the value of coefficient of static friction is greater than value of coefficient of kinetic friction. This is logical answer, so our answer is correct. Thank you very much for watching this video.